Alright guys, we are going to do L'Hopital's rule. As you can skim the page here, we're going back to limits. So remember that a limit is about where it's approaching. Okay, so before we were using plugging in and finding algebraic methods to be able to cross out and to figure out where it belongs to. But some limits cannot be found using algebraic methods. If directly substitute, so we directly substitute in the number and we are producing 0 over 0 or infinity over infinity, which we know is an indeterminate, we can use the rule, L'Hopital's rule. So in the past, guys, when we substituted in the number and we got an indeterminate like this, we would see if there was any way for algebraically that we could cross things off, like factor and things like that. But what happens when we're dealing with stuff that's not easy to recognize? Well, we can use L'Hopital's rule. So here it is. If we find the limit as x approaching c and f of x equals 0, limit of x to c is g of x equals 0, or if both of these limits are positive, negative, infinity, then we could say f of x, the limit of f of x over f of g. So again, there's that indeterminate, 0 over 0, infinity over infinity. What we can actually do to find the limit is also take the derivative of the numerator and derivative of the denominator. So we want to remember that it has to be the indeterminate first. So what we're going to do is plug in first. As you can see, if I were to plug in infinity, I would get infinity over, and then if you have no calculator, imagine what the graph V looks like. As we go to infinity, our arrow is pointing up to infinity. So we get infinity over infinity. This is an indeterminate. So that's allowing us to say that we can take the limit as x approaches infinity and take the derivative of the numerator. Well, the derivative of x is 1, and the derivative of e to the x is e to the x. Okay. Now if we plug in, we would get 1 over infinity. Well, 1 over infinity is a very, very small number. So if we go down to the smallest number we get, what do we get, guys? We get 0. Let's do it with this one. If we plug in infinity, we would get infinity over infinity. So let's do our L'Hopital's rule. We get limit as x approaches infinity. See, the derivative of e to the x is e to the x. Derivative of x is 1. When we plug that in, we get infinity, but we know, right, e to the infinity is infinity. Either you can put infinity down or does not exist, right, because we'll never get there. Excuse me. Alright, remember the first thing we have to do is to check that it's indeterminate first. So the way to do that is to plug in. So if we substitute in 0, we get 0. E to the 0 is 1. Well, what is 0 over 1, guys? It is 0. So we don't even have to do L'Hopital's rule for that one. Okay, what does it mean for the left side? Okay, remember we're talking about the left side of 0, so that means our negative numbers, okay? So, e to the 0 is 1, but if you're talking about 0 from the left side, we are talking about what type of numbers? Negative numbers. So, okay, we are going 1 over very small numbers. If you think of small numbers, we divide by the reciprocal. So let's say negative 1/2, right? We would get negative 2. If we went 1 divided by negative 1/4, we would get negative 4. What's happening each time? We're going to negative infinity, which we can either keep that as negative infinity or say does not exist. Number 5, let's plug in. When we plug in 0, we get 0 on top. When we plug 0 on the bottom, 0 on the bottom, so we get our indeterminate, which means that we can take our limit as x approaches 0 and do our derivative. So we get negative 9e to the 3x all over 1. We plug in 0. Well, that's 3e to the 0 is 1. 1 times negative 9 is negative 9. Okay. Some tips. Do not use L'Hopital's rule just because a problem looks like a candidate. So as we can see up here, 3 and 4 were not candidates for L'Hopital's rule, because when we plugged in, we did not get an indeterminate. So be careful on that. Okay, so if L'Hopital rule leaves you with indeterminate again, we can continue using the rule, guys. So we can repeat it as much as possible, but we can only use this rule if we have indeterminate. Okay, so let's look at some of these examples down below. If we plug in negative infinity on top, well, negative infinity squared is infinity. And if we plug it on the bottom, we would get, let's see, e to the negative infinity. Well, e to the infinity is infinity. So we have our indeterminate. So let's take our derivatives. X to the negative infinity. Derivative on top would be 2x. On the bottom would be negative e to the negative x. Let's plug in there. So when we plug in negative infinity times 2, we get negative infinity. When we plug in negative infinity in here, we get negative infinity. So that's indeterminate yet again. So let's take the derivative of this new stuff. So the derivative of 2x is 2. And the derivative of negative e to the negative x is e to the negative x. So we get 2 over, if we plug negative infinity in, we get infinity. Well, 2 over a big number will then reduce down to getting close to 0. Okay, 7. Let's plug in 1. ln of 1 is 0 minus 1 plus 1. That gives us 0 on top. 1 minus 2 plus 1. That gives us 0 on the bottom. So we have our indeterminate. Let's take our derivative. So I get 1 over x minus 1 on top. On the bottom I get 2x minus 2. Well, when I plug in 1 again, I get 0 on top and I get 0 on the bottom. So let's do it again. Limit as x approaches 1. We get If I take the derivative of the numerator, I get negative 1 over x squared all over 2. When I plug that in, I get, let's see, plug 1 in there, I get negative 1 on top, 2 on the bottom. So our answer is the limit to negative 1/2. So recap, L'Hopital's rule allows us to go a step further if we are given an indeterminate after we substitute in our limit.